Investigations are hard work. They're time-consuming and often involve complex data. AI can help, but journalists don't always have the right training or access to the right tools. In the latest installment of our oral history project, we meet a scientist who's been supporting these deep investigative projects for more than a decade. This collaboration has helped to uncover things like Russian interference in the 2016 election and one of the biggest ever global corruption scandals, called the Panama Papers, an investigation that was awarded the Pulitzer Prize. I'm Jennifer Strong, and this is Shift.
Now here on the steering column is a device called Auto Cruise. You simply set the speed you want.
Self-driving robo-taxis are already on the road in US cities.
As the disc rotates, a mirror reflects the light in the way that depends on how the signal was recorded.
This is the 100 terabyte I present to you Electro, the Moto Man.
Ladies and gentlemen,
I would say that one of my greatest skills is my ability to interact with humans.
This episode, we meet Dr. Jim Weber, the chief scientist of Neo4j. Support for this podcast comes from Motific, bridging the gap between concept and deployment by accelerating deployment and helping ensure compliance throughout the process. Visit motific.ai to learn more.
Hello, my name is Jim Weber, and I am Neo4j's chief scientist. Terrible name, isn't it? It's not very self-explanatory. But actually, Neo4j is the graph database company. So we pioneered this new data model, or old new data model, as I think some folks will see it, where instead of storing our data as spreadsheets, as traditionally databases have done in tables of data or columns of data or documents of data, as some more modern databases have, we store data as a network of interconnected facts. And it turns out that that is a very useful data model for modeling all of the complexity and intricacies of the modern world. And despite the fact that I think we've got an absolutely terrible name, that eponymous database has gone on to be used in a wide variety of industries. And I think, particularly germane to this conversation, is widely used in journalism as well. So I could say, for example, on a whiteboard together, we could draw a network of how we might know each other. And I realize that we've only recently met for the purposes of this podcast. But for example, I might say that draw a circle, that's a node, that's an entity. And I say, well, that's Jim, that's me. And I might draw an arrow and to another circle and write London in it. And I might write lives in on that arrow. And we can then read that as Jim lives in London. Simple diagram, simple picture. And I could write also for you, I could write, Jennifer lives in New York City. Then you think, well, how do we know each other? Well, I guess we could draw a node that represents the Shift podcast. And we could say, Jennifer presents Shift podcast and Jim participated in. And if you looked at that very simple network, you'd be able to read it as something like Jennifer hosts the Shift podcast from New York City and Jim participated from London. So you can see already in that sentence, so there's a lot of complexity there. There's a lot of linguistic complexity. There's lives in, there's hosted, there's podcasts, there's people, there's locations. That kind of data is actually quite awkward to handle when all you've got is a spreadsheet-like structure. You end up with big blanks everywhere or adding columns and all that kind of stuff. And it turns out to be a real pain, not only in terms of modeling, but also in terms of performance. But when you model this as a graph, it's really pleasant. You and I could, as I said, we could draw this on a whiteboard and within 30 seconds, you'd get it, that the idioms are very basic. And we'd be able to draw these high fidelity models of the world. And then our job as a database vendor is to make sure that we can store that data safely and that you can query it very quickly. And of course, you can see how, as a journalist, having access to a network of facts allows you to store a rich picture of your domain that under scrutiny, a thing that you're interested in, and be able to query it for things that are of interest to you. Are there people connected in some way that shouldn't be? Are there clumps of people operating almost like a little terrorist cell in this graph? And what are they doing? Are they helping each other? Are they colluding in some way that I'm suspicious about? Are there money flows through this graph? Are there financial transactions that I'm interested in? You see, so it provides this really rich lens into otherwise worlds that are really murky to see because you can't see the connectivity in other data models. we have this kind of idea that we want data to do good in the world. Don't get me wrong, we're a business, and part of our business is selling database licenses so we can get wages and pay the rent and so on. But we're also so optimistic for the way data can be used in the modern world. And so one of the things we've done historically is support journalism, which can make use of this data technology. So, for example, for a long time now, we've had a strong relationship with the ICIJ, the International Consortium of Investigative Journalists. I guess they're most famous from kind of Panama Papers, Paradise Papers, that kind of stuff. And you've got to feel for these folks. As a computer science person, sometimes it's very easy for me to kind of see how data should fit together. But as a journalist, you've got very different training. And so when the ICIJ folks first received this trove of data, which potentially had some very interesting and alarming data in it, their only option was to kind of manually go through it. And of course, with terabytes and terabytes of data, that's prohibitive. It's, where do you find the needles in the haystack? So what they did was they built a kind of processing pipeline which sort of inspected some of these documents in an automated way and started to spit them out into this network, into this graph structure. So they could start to see the links between the graphs. And the one that I particularly loved was the former Icelandic prime minister. I say former because he got caught out rather badly. And he said he was on TV in the middle of an interview, and the interviewer rightly asked him some very pointed questions about his involvement in such and such a financial arrangement, which he flatly denied. Unfortunately for him, the ICIJ had managed to pull together a graph of his social network, including his wife, who used to be known by a different name, by her maiden name, but who cohabited with this other guy who happened to be the future prime minister at a particular address. So they found by following the links, almost like following, forgive my parochial explanation, but by following the dots on a tube map here in London, they managed to find a common station, in this case, a common address where they both lived. And they demonstrated that there could well have been collusion. To his credit, the former prime minister immediately understood he'd been rumbled and did the honourable thing. But without this idea of a graph structure that kind of leads you, like a map of the territory, if you like, without that, it would have been impossible to find that kind of collusion. And so, of course, the ICIJ are kind of one prominent example of this. But then more recently, we've been working with Syracuse University. And they're doing something which, again, is quite close to my heart, which is to make sure democracy stays on the rails. So, of course, this year in the UK, and I think even higher stakes, the presidential election in the US later in the year, there's a lot of misinformation around. You maybe see it yourself. In my social feeds, it's full, or at least in the UK, noise. And it was sometimes hard to disambiguate the signal from the noise. Because I think the noise or the misinformation is becoming ever more skillful, particularly as people are using learned models and generative models to be able to generate it. And so what the folks at Syracuse are doing is they're trying to follow the money. And so they're using the graph technology to build a graph and network of advertising spending. And you can, again, just like the tube map analogy, you can start to follow the dots and the lines in the graph. And then you can find who's spending what money on whom. And then you can start to look for subgraphs or components, as we call them in the graph, people that are kind of not explicitly saying they're working together, but whom the data strongly suggests are colluding in some way. So instead of one person being seen to spend $1 billion, you've got thousands of people all spending hundreds or thousands of dollars. So it doesn't really raise any individual alarms, but in aggregate, you can see this kind of cooperation going on to potentially pump either information or sometimes disinformation, or actually, as the Syracuse folks have found at the moment, a lot of scams that prey on people's political allegiances, and be able to analyze those and just see who's paying for what, where the money's going, and therefore what the meta political landscape really is. So I think one thing that's definitely making the job of managing disinformation and misinformation harder is that the generative AI capabilities are strong and becoming stronger. Now, look, as a journalist, I'm sure when you read Gen AI content, to you, it's somewhat obvious. Although I bet if we have the same conversation 18 months, 24 months from now, maybe even you as someone who is strongly literate would start to question, I'm not sure if this is human or not. So I think that's definitely got its finger on one side of the scales, making it harder. I think Gen AI content is good enough that it passes for reputable human for a large part of the population of the United States, and certainly here in the UK. I think on the other side of the scales, pressing the other way, the kind of technology that the folks at Syracuse, similarly the folks at ICIJ and other data journalists are developing using things like graph tech and so on, that's also ever stronger. So they're able to start spotting those intricate patterns in a way that they've never been able to do before. And I think really importantly, the technology is becoming humane. And that's important, right? Because when I first picked up graph technology many, many years ago, the actual model was really great. It's that, circles connected by lines kind of tube map model. And that hasn't changed. That's still amazing. That's really what dragged me in. But as a technologist, even I thought, well, blimey, this stuff is hard to use. In fact, I remember telling some guy who's now the CEO of Neo4j, my boss, like, man, like the model's great, but your technology stinks. And so one of the reasons I joined Neo4j was to try and make it easier to use. And I think what's happening now is that we've gotten to a state where the technology is easier to use. So just in the last half year or so, you as an independent journalist, you could, for example, you've come across a trove of web pages, PDFs, whatever. You can now literally just drag and drop those onto Neo4j, and it's going to build out what's called a knowledge graph for you automatically. And of course, actually in the background, rather fittingly, it's actually using a generative API, it's using a large language model to sift through the words and classify them and tokenize them and all that clever stuff. But then it's automatically going to build one of these graphs for you. So then you've got kind of like a digital forensics board, the kind of thing that I see on American cop shows, right, with pinboards and string. But imagine that to scale with millions or billions of entries and connections in it. So you get this really rich picture of what's going on in that data. And that, to be honest, like that to me almost seems like science fiction. 3 years ago, I genuinely couldn't have imagined that happening. I could imagine, big and you kind of carefully built data pipelines like the ICIJs, but being able to drag and drop that on your desktop would have seemed like sci-fi. Today, you can do that. You can take a break from this podcast, drag a few PDFs onto the knowledge graph builder, and bam, you've got a data set there that's ready to use. And I hope that for folks like yourself and other data journalists, that's again going to tip the scales back the other way a little bit, kind of redress some of that balance that the misinformation, disinformation people have just by making this technology far easier to use.
Support for this podcast comes from Outshift. Cisco's incubation engine's newest AI innovation, Motific, is bridging the gap between concept and deployment, accelerating deployment while reducing security, trust, compliance, and cost risks. Motific provides advanced policy controls to prevent unauthorized access to sensitive data and helps ensure compliance throughout the process. Visit motific.ai to learn more. This episode was produced by me and Emma Silikans and mixed by Garrett Lang, with original music from him and Jacob Gorski. Thanks for listening. I'm Jennifer Strong. Support for this podcast comes from Outshift. Cisco's incubation engine's newest AI innovation, Motific, is bridging the gap between concept and deployment, accelerating deployment while reducing security, trust, compliance, and cost risks. Motific provides advanced policy controls to prevent unauthorized access to sensitive data and helps ensure compliance throughout the process. Visit motific.ai to learn more.